This is predicting refractive error from visual acuities for V551, ocular motility and refraction. Let's take a look at this ISO acuity chart from V550 Clinical Sciences 1. It's a pretty confusing chart, and that's because it's from 1932 in different shades of gray. So let's modernize it just a little bit. Here we color-coded it using hot and cold colors to give you an easier idea to interpret this chart. Just like before, we have the sphere powers from -2 to +5 on the horizontal axis. We have more astigmatism on the vertical axis from 0 to 4 diopters of astigmatism. As we increase the amount of refractive error, either sphere or cylinder, we decrease the acuity, with redder colors being lower acuities or worse acuities, and cooler colors like blues and purples being better acuities. But all we really care about is a small subset of these acuities. Anything outside of this range is too difficult to predict refractive error from because the patient sees so poorly you have no idea what the prescription could be. It could be a wide range. However, within this range here, most patients, 90 to 95% of patients that come into your practice will be within this range of acuities when they come into the practice. And so that's why this range is where it's critical that you know to be able to predict acuity. Let's use a couple examples. Patient number 1 comes in with a chief complaint of distance blur, and the right eye, through no prescription whatsoever, plain no prescription, sees 20/30 on entering acuities. Patient 2 has a chief complaint also of blurry distance vision, but his prescription is -6 diopters. But his VA still is 20/30 through that. Well, what's our predicted change in refractive error? It's a half diopter sphere in both examples. And that's for a very good reason. Within that range, most people come in, 90–95% of the patients, with their glasses on. So when we're actually measuring acuities, we're measuring a change in refractive error, not the refractive error through the without glasses on, correct? Well, that also matters if they have accommodation or don't have accommodation. On the left, we have that same chart with accommodation. With accommodation, that patient can actually correct their hyperopia, so they see 20/20 through a wide range of acuities. And it also allows them to modify the spherical equivalent of their own astigmatism, so it reduces the effect of astigmatism with more hyperopia. Conversely, though, patients without accommodation, patients over the age of 40, have equal effects from both plus and minus sphere powers, and so this range changes with age. And so it's important to understand if your patient is older or younger and the amount of accommodation, how that will affect their acuity and their vision. Guiding rule number 1 of refraction and prescribing: never start refracting without knowing where you expect to go. And that's the point of predicting refractive error before you get started. It gives you a good idea of where you're going to go with the refraction. It's essentially you're coming up with a hypothesis of what that change in prescription is, and then you'll go and test it through the refraction process. That gives you a guide to know where you're going. Well, how much prescription change is needed to reduce visual acuity by one single line? Well, again, it matters with accommodation or without. With accommodation, hyperopes, it could be a wide range of prescriptions where it won't reduce their acuity at all for distance because they can accommodate. Conversely, a myope at distance, a quarter diopter will actually reduce their acuity by one line. And for astigmatism, depending on the amount of hyperopia, it can be a half diopter changes one line of acuity. Now, without accommodation, though, both hyperopia and myopia change equally amount. 1/4 diopter change in refraction will reduce acuity by one line. Similarly, astigmatism, a half diopter per half diopter will change by one line. Now, what happens when we get in a situation where we have hyperopia and astigmatism? Well, that's a mess that we typically don't consider in clinic, and we just have to live with the longer prescription refraction times. Number 2, how types of refractive error primarily affect the location of reduced acuity? With accommodation, hyperopia primarily affects near, and that depends upon the amount and the age of the patient, how much accommodation they have. Conversely, myopia mainly affects distance. So we expect their near to be relatively clear depending on the amount. Again, high myopes, 6, 7, 8 diopters might still be blurry at near, but they'll see better at near. Also, astigmatism, it affects typically both distance and near. So when you see acuity reduced at astigmatism, you expect that both distance and near to be affected. Now let's look at without accommodation. Without accommodation, hyperopia, the near is typically worse than the distance. However, without accommodation, depends on how much accommodation they have left. If they have a little bit left, they still may be able to clear their distance. Myopia, though, is still distance, and astigmatism affects both, just like before. Let's look at some examples. The first patient we see comes in seeing 20/50 at distance, right eye, 20/60 at distance, left eye. At near, they see 20/40 and 20/40 in both eyes. Since the distance is worse than the near by 1 line in the right eye and 2 lines in the left eye, we expect the myopia to be a little worse by 1 to 2 lines. The patient also has accommodation, so it's probably not hyperopia or anything like that. In this case, we consider their sphere power, the right eye to be a quarter diopter because it's 1 line, and the left eye to be 2 lines of acuity or half diopters of myopia. However, both lines were reduced by 3 lines, right? 20/40, 20/30, 20/25. That's 3 lines. So we expect a half diopter per line. So we're expecting now a 1.5 diopter astigmatism change in our prescription. We don't really know the axis since the axis is unknown. So we're going to assume a 180 in this case. Let's look at our other patient. In the same situation, they both see distance the same as the first patient. They see 20/50 in the right eye, 20/60 in the left eye. But in this case, their near acuities are 20/20 in the right eye and 20/25 in the left eye. Since the distance is worse than the near by 4 lines in both eyes, we consider a quarter diopter per line. The sphere power we expect in both eyes is 1 diopter. Now, the mutual difference between the left eye is 1 line, so the patient has no lines blurred at both distance and near right eye. However, he has 1 line blurred in the left eye, or a half diopter per line. Our sphere's powers remain the same, and our left eye now becomes a half diopter of astigmatism at 180. Now let's look at an example of a patient without accommodation. In their right eye, they see 2200 entering in the first patient, and at near, they see 20/20. The patient is worse at distance than near. In fact, the patient sees perfectly 20/20 at 40 centimeters with no accommodation. This tells us that all the prescription is myopia. So we can assume that they are approximately a 2.5 diopter sphere in both right eye and left eye. Since there's no reduction at both distance and near, we expect there to be no astigmatism. So the predicted distance Rx is a -250 sphere, OD and OS. Let's look at a second patient. In this case, they see 20/50 at distance and 20/60 at near. At distance, they see 20/50 at right eye and 20/60 left eye. At near, they see 2200 both OD and OS. Near vision is so poor we can't estimate well. This patient probably has no accommodation, so they need probably a 2.5 diopter at near. But the VA still reduced 4 lines OD and 5 lines OS, or a quarter diopter per line and a half diopter per astigmatism. We cannot guess the direction because the patient has no astigmatism. So this gives us a wide range in this case. They could have between -1 and +1 diopters of power and up to 2 diopters of astigmatism. So it depends upon their age, their refractive error, and their acuities both at distance and near. Thank you.